Hello guys, welcome to my channel. So here we are back with one more video of the current series of Java developer interview questions. So in the last video we talked about streams, lambda expressions and function interfaces. Now in this video we are going to talk about Spring Boot. So if you haven't seen all the previous videos till now, please do watch them. It's all there in my channel, you can take a look. And if you are new to my channel, if you haven't yet subscribed to my channel yet, please do. It's a humble request because it is going to keep me motivated to make more videos like this. And now let's talk about Spring Boot. Now let's start with the very first question. How does Spring Boot optimize dependency injection with its auto-configured mechanism? So if you don't know, dependency injection is a very core concept of Spring Boot, and this is just an implementation of IOC, which is inversion of control. Now talking about this specific question, so there are a few things that we need to talk about. So first is we need to talk about conditional configuration, then bean duplication, lazy initialization, and then environment aware configurations, use of enable auto configuration, predefined auto configuration modules, profiles for conditional injection, and so on, right? So these are some of the parameters on which we can say that Spring Boot optimized dependency injection. Now talking about the very first topic, which is conditional configuration. So Spring Boot uses annotations like conditional on class, conditional on missing bean, and conditional on property. So these are the annotations to conditionally configure beans. Now this ensures that only the necessary beans are created, and then it avoids redundant or conflicting configuration. So if you take a look at this example, here we have a conditional on missing bean annotation. So this configures a bean only if there isn't an existing bean of the same time. So here we are actually trying to remove conflicts, right? So it avoids that. Now second topic is bean deduplication. Again, same thing. So when we use conditional on missing bean annotation, we check for existing beans, and here Spring Boot prevents duplicate bean creation. So this avoids unnecessary overhead and ensures that user defined beans take precedence over auto configured ones. Now we have lazy initialization. So lazy initialization is not actually a Spring concept. It can be used in any programming logic or code possible. So Spring Boot supports lazy bean initialization, where beans are initialized or instantiated only when they are needed, right? So that is the core concept. Whenever you require bean, then only instantiate, otherwise leave it be. Now this reduces startup time and memory usage for applications that don't require all beans immediately. So for this you just need to add a single property line in your application.properties or YAML, and you are good to go. Now use of enable auto configuration. So this configuration annotation scans for your files to discover and load auto configuration classes. So this is a very big annotation. So these classes contain logic to set up commonly used beans like your data source, REST template, entity manager, etc. So Spring Boot application annotation by default uses enable auto configuration. So if you know about it, this uses 3 annotation basically, and enable auto configuration is part of these 3. Alright, now we are done with the first question. Second question is, what is the purpose of the primary annotation? How does it interact with qualifier? So primary and qualifier annotations are being used to resolve ambiguity when multiple beans of the same type exist in the application context. So primary annotation designate a bean as the default choice when multiple beans of the same type are available. So this reduces the need for explicitly specifying which bean to use in most cases. So if you take a look here we are specifying that use this bean and not the other one. So here in the example you can see that in the injection class, my service class basically, we have a data source object with us. So here what we are trying to do is, here we are trying to initialize it. but which one to use? So here we have two options. We have primary data source, we have secondary data source. So when we annotate a proper object with primary annotation, then that means that use this one and ignore the other one. So when we talk about qualifier annotation, so this allows you to explicitly specify which bean to inject when there are multiple candidates, overriding the default behavior including primary. So if you take a look at the example, here we have the same data source configuration, and then in the my service class you can see that I'm specifying with the qualifier annotation that use secondary data source and not the primary one. Alright, now you can combine both of these two as well, so you can use both primary and qualifier annotation. So if you take a look here in this example, here we have the primary annotation, and this means that this is going to be used by default. But when we use qualifier along with it, then the qualifier takes precedence and qualifier one will be picked up. Now let's move on to the next question. Explain the difference between configuration and component in the context of creating beans. So configuration annotation is used to define a class as a Java based configuration class, that's in the name, and it is part of Spring Java config approach for configuring the application context. So the purpose of configuration annotation is to declare a class as a source of bean definition, and this allows defining beans using the bean annotation. So where to use it? Use it for explicit and programmatic configuration of beans. Now what are some advantages? So it provides explicit and centralized control over bean configuration, and it supports integration with external property files, conditional bean creation, and programmatic logic for bean definition. Now talking about component annotation, this is used to declare a class as a Spring managed bean. So configuration was Java based configuration class or Java config, but this is Spring managed bean. So this is a part of Spring's component scanning mechanism, which automatically detects and registers beans in the application context. So the purpose is to mark a class as a Spring managed component or bean, and this works with component scanning to register bean automatically. Now here the advantage is to reduce boilerplate code for declaring beans, and this leverage convention over configuration for quick and straightforward bean management. Now the straightforward difference between configuration and component is that how to use it. So if you want to have a programmatic approach to define bean dependencies, then use configuration, because it will give you a control, basically more control over component annotation. So component annotation handles dependencies through annotation, that's it, right? So this is used for marking individual component, but configuration is used for Java based configuration. And to create bean you have to explicitly use bean methods, but in component it is implicit via component scanning. All right, now let's move on to the next question. Explain the difference between bean scopes in Spring. So we have singleton, prototype, request, session, and HTTP session. So we have 5 bean scopes. So talking about singleton, it's straightforward. So this means that a single instance of the bean is created and shared across the entire Spring IOC container. Don't forget to use the word Spring IOC container, because this is not your singleton design pattern. This is something else. This is not with your entire application. This is just with a single Spring IOC container. So the scope is that there is no scope. So this is by default. So if you don't specify the bean scope, then singleton is your by default choice. Right now, talking about prototype scope, so this means that a new instance of the bean is created every time it is requested. Now request scope is when a new instance of the bean is created for each HTTP request. So the bean lives as long as the request and then it dies. Now session scope, so a new instance of the bean is created for each HTTP session. So request was for a new HTTP request, but session is for a new HTTP session. So here the bean lives as long as the session, and in the request the bean lives as long as the request. As simple as it is. Now talking about global HTTP sessions, so this means that a single instance of the bean is created for the entire web application. Okay, so this is like a bigger brother of your session. So this is shared across all the HTTP request and session. Alright, I hope this is clear now. Now, what is dependency injection and how does Spring implement it? So like I told you before, Spring core concept is dependency injection, and that is how it has become more popular. So like I told you, this is a design pattern used to achieve inversion of control, and the key concept are your dependency and injection. So dependency means that any object that a class needs to perform its task. Injection is the process of providing these dependencies to the class. Alright, so how does it work? So instead of a class creating its dependencies using new keyword, they are provided by a framework. They are provided by Spring. So this promotes loose coupling, making the system easier to test, maintain and extend. Now there are a few types of dependency injection. We have constructor injection, we have setter injection, and we have field injection. So this is your next question as well, but let's talk about it here. So constructor injection is the dependencies that are passed via the class constructor. Alright, so you can take a look at this example. Here we have a service constructor, and this is how you actually pass the dependency. Now in the setter injection, like the name suggests, you use a setter method, and you can see it in the example. Now field injection is your variables or parameters, whatever you call it. So dependencies are injected directly into the fields, and here you need to use auto-wired annotation, and this is the more preferred way to achieve dependency injection, and I use it as well. Now here there is a default dependency injection. So if you don't specify anything, then the default dependency injection is constructor injection. Alright, so what are some of the benefits of dependency injection? First is loose coupling, second is improved testability, third is reusable code, fourth is ease of maintenance. Alright, so let's talk about what is the difference between auto-wired and inject. So inject is also here for dependency injection. So the key difference is in the origin. So auto-wired annotation is part of Spring framework, and it is from your annotation package. But inject is part of Java's CDI, which is your context and dependency injection. So this is defined in Java x.inject package. So this was introduced in Java EE 6. Alright. So origin I have talked about. Now frame dependency. So auto-wired annotation requires Spring framework to work. But for inject annotation, as this is a part of Java standard, so it is portable across CDI compliant frameworks, example Spring, Juice, anything. Now auto-wired has a required attribute to specify if a dependency is mandatory. So required is true by default, but you can make it false. In inject, it does not have a required attribute. This requires additional handling for optional dependencies. Now the primary use of auto-wired annotation is in Spring application, but inject annotation can be used in both Spring and other CDI compliant frameworks. Now auto-wired works seamlessly with qualifier annotation to resolve ambiguity, and inject also works with a named attribute for resolving ambiguity. Now auto-wired can be used with Spring specific features like lazy annotation or scoped proxies, but inject is limited to the features provided by CDI. Now auto-wired, like we talked about, it supports injection into field, constructor and setters, and same is the case with inject annotation. So it supports injection into fields, constructor and setters. So though the question was related to the difference between these two, and we have talked about a lot of similarities because they kind of are similar, right? Now let's move on to the next question. What is the role of Spring Boot application annotation? How does it combine multiple annotation? Now Spring Boot application annotation is a very key component because this is your first annotation which anyone will see when you create your Spring Boot application. So this serves as a convenience annotation because it combines several other annotation to simplify configuration and startup. So annotations that are combined here are your configuration annotation, enable auto configuration annotation, and lastly component scan annotation. Now why do we need these three? So enable auto configuration we have already talked about, because this enables Spring Boot's auto configuration feature. Now this automatically configures Spring components based on the class path dependencies. So this is a very heavy feature. But talking about configuration annotation, this indicates that the class is a source of bean definitions for the Spring application context. And this allows you to define beans using bean annotation methods. Alright. Now component scan, this enables component scanning in the package of the annotated class and its sub packages. So this automatically detects Spring components like your component annotation, service, repository, and controller. So whenever you work on an application, you need to use these three annotation, or you can just use Spring Boot application. So how does this work? So when you annotate a class with a Spring Boot application annotation, so first it scans the package and the sub packages for Spring components, configuration, and beans. Then it auto configures necessary components based on the dependencies in the class path. Then it starts the embedded web server. By default it's Tomcat, but you can change it. Now also this acts as the entry point for the application. Alright, now let's move on to the next one. What is the difference between application.properties and application.yaml Spring Boot? How do profiles work with these files? So the first question is very easy. There isn't much difference between these two. It's completely based on usage and readability. So some people refers to YAML because this is more readable, so they use it, and like people like me use properties file because we have the habit of using properties file, so we are basically clinging on to it. Now these two files are the basic way to provide the configuration for your Spring Boot application. So this file, application file, is very important. So both serve the same purpose but differ in format and structure. So your application.properties is a key value pair format and your YAML is a YAML format. So this is hierarchical. Now the second question, how do profiles work with these files? So here we are talking about Spring profiles. So Spring profiles allow us to define environment specific configuration, enabling our application to run with different environment like your dev, test, prod, depending on the active profile. So like we have two options now, properties or YAML. But when you define a property in both of these two, which is your Spring profiles active, so you have to give it the environment name. So it could be dev, it could be test, it could be prod. And similarly you will have these files as well in your application. So the name should be something like application-dev, application-prod. So depending on what you have put up in your main application or properties, it will pick up the file and run the configuration. Alright, now the last question, explain how Spring Boot manages externalized configuration using configuration properties. So in Spring Boot, externalized configuration refers to the practice of separating configuration values such as database URLs, API keys, and application setting from the application code. So this allows them to be specified outside the application itself, that is in your property files. Now this allows flexibility in managing settings for different environment, like you can use Spring profiles here. So one of the most powerful way to manage externalized configuration in Spring Boot is using configuration properties annotation. This annotation binds external configuration properties like your application.properties to Java objects. So this annotation enables a more type safe and flexible approach to externalized configuration. This allows you to map an entire configuration structure into Java object. Now how does it work? So when you create a Pojo class, so this class has to be annotated with configuration properties annotation. Then it maps to a prefix that corresponds to the configuration properties. So the properties in the class should match the names of the external configuration keys, right? Now enable configuration properties to make Spring Boot aware of this class and enable its binding. So we typically annotate the main class with enable configuration properties annotation, and that is how you enable it. So if you take a look at this example, so here we have first defined the configuration properties, and you can see it here. So we have two formats. We have application.properties, we have application.yaml. Now we have created a Pojo class where we have configuration properties annotation and the prefix is app. Now the configuration properties annotation binds the properties that start with app to this class, and the nested data source class is used to map app.dataSource properties. Now use the configuration properties annotation class in your application. So Spring Boot automatically binds the values from the application properties or YAML to the fields in the app config class. Now here in the app controller you can see that when you access the config endpoint, it will return the values from the application.properties or YAML that are bound to the app config class. Alright, so this all happens automatically. And enable configuration properties annotation. Now you have, so in Spring Boot 2, configuration properties annotation is enabled by default for classes annotated with component configuration or Spring Boot application. So if not using component, we can explicitly enable the binding with enable configuration properties. Alright, so now we are done with Spring Boot. So this was it for this video. I really hope that you loved the content that I have shown in this video. If you learned anything new, just press the like button and comment if you have any questions. Don't forget to subscribe. In the next video of this series, we are going to work on microservices. So stay tuned for that. Till then, keep learning, stay happy, and bye-bye.